Question 1. What physical angle of incidence allows laser light to pass through an optical window without experiencing any reflection losses for p-polarized light? Brewster's angle is the specific angle of incidence where light with p-polarization experiences zero reflection at a clean dielectric interface, maximizing cavity transmission. Question 2. Which solid-state laser uses a synthetic crystal dopant of neodymium ions in an yttrium aluminum garnet host to emit light at 1064 nanometers? The neodymium-doped yttrium aluminum garnet, or NdYAG laser, is a highly popular solid-state laser producing powerful industrial and medical beams at 1064 nanometers. Question 3. What fundamental thermodynamic parameters describe the probability of spontaneous emission and stimulated emission inside a gain medium? Einstein coefficients quantitatively establish the transition rates of spontaneous and stimulated processes, outlining the quantum kinetics of optical gain. Question 4. What structural design features are integrated into modern laser diodes to confine carriers and optical fields simultaneously in a tiny active region? Double heterostructured junctions confine both electric charge carriers and optical waves into the same microscopic zone, drastically lowering the current needed to start lasing. Question 5. What optical component is placed inside a laser cavity to force it to operate in a single, ultra-stable longitudinal mode? A Fabry-Perot-Etalon is an adjustable, highly reflective optical plate assembly that filters out adjacent cavity frequencies, forcing single-mode emission. Question 6. What nonlinear optical phenomenon causes an intense laser beam to self-focus inside a medium due to spatial variations in beam intensity? The Kerr lens effect occurs when an intense spatial profile alters the medium's local refractive index, transforming the material into a focusing lens for the beam. Question 7. In a carbon dioxide gas laser, what type of molecular transition is primarily responsible for generating the intense infrared beam at 10.6 micrometers? The carbon dioxide laser operates by transitioning between asymmetric stretch and bending vibrational energy levels, producing highly efficient infrared beams. Question 8. What safety classification is given to high-power lasers that can cause immediate, permanent eye injury from direct, specular, or diffuse reflections? Class 4 lasers are high-power devices capable of causing instant, catastrophic skin and eye damage, even from scattered diffuse reflections, demanding tight safety protocols. Question 9. What optical device is integrated into laser systems to allow light to travel in only one direction, protecting cavities from harmful back reflections? An optical isolator works as a one-way valve for photons. By leveraging the magneto-optic Faraday effect, it stops backward reflections from destabilizing the laser. Question 10. What type of laser uses an optical fiber core doped with rare earth elements like ytterbium as its active gain medium? Fiber lasers use a doped optical fiber core as their active medium. Confining the pump light inside the core yields unmatched beam stability and excellent heat dissipation.